Hi Dr. Forward, my name is GOH CHANG ZHE from section 6 and I'm going to start demonstrate lab 2 question 1. So before I start execute every single line, I want to explain that in the data section I initialize var1 with decimal value of 1 in word size, which is hexadecimal value 1, and var2 in decimal value of 9 in word size, which is hexadecimal value of 9. And then I'm going to start execute every single line by pressing F11. Okay, so for the first line, move x var1. That means move the value of var1 into x register. For now, the value of x is ff58 and the value of var1 is 1. So after execute this line, I expect the value of x will be 1. As you can see, the value of x has become 1. And the next line, move bx var2. That means move the value of var2 into bx register. The value of var2 is 9, and I expect after I execute this line, the value of bx will become 9. Currently, the value of bx is d000. So you can see that the value of bx has become 9. Next line, exchange x bx. That means it will swap the value of x register with the value of bx register. For now, the value of x is 1 and the value of bx is 9. So after execute this line, I expect the value of x will become 9 and the value of bx will become 1. So the value of x has become 9 and the value of bx has become 1. The value has swapped. And then next line, move var1 ax. That means move the value of x register into var1 variable. Currently the value of var1 is 1. You can see in the watch 1 window. And after execute this line, I expect it to become 9. So you can see that the value of var1 has become 9. Next line, move var2 bx. That means move the value of bx register into var2 variable. So currently the value of var2 is 9. After execute, I expect it to become 1. So after execute that line, the value of var2 has become 1. Next line, call dumrex. This will display the value of register. You can see that the value of the register has displayed. Same with the register window. The x is 9, and the bx is 1. 9 and 1. Alright, then exit. That's it. Hi Dr. Forward, my name is GOH CHANG ZHE and I'm going to start demonstrate lab 2 question 3. So before I execute every single line of this code, I want to explain that in the data section, I initialize var1 with decimal value of 5 in d word size, which is hexadecimal 5. And then var2, I initialize it with decimal value of 10 in d word size, which is a in hexadecimal. And then for var3, I initialize it with decimal value of 20 in d word size, which is 14 in hexadecimal. For var4, I don't initialize it with any specific value, so for now it be allocated, but for the value it is 0 for now. And then I'm going to start execute every single line by pressing F11. Okay. So for the first line, move ex var1. That means the value of var1 will be moved into ex register. For now, the value of ex is 009EFDD4. So after execute this line, the value of ex will become 5. Right, as you can see, the value of ex has become 5. And the next line, mul var2. That means it will multiply the value of ex with var2, and the result will be stored in ex. So the value of ex for now is 5 and var2 is 10. So 5 multiplied with 10 will be 50 in decimal, but in the register the value would be displayed is in hexadecimal. So 50 decimal is equal to 32 hexadecimal. As you can see, the value of ex is 32 now. And the next line, add ex var3. That means the value of var3 will be added to ex register. So as you can see, the value of var3 is 14 hexadecimal. You can see in the watch 1 window also. So 32 h plus 14 h is 46 h. So I expect the value of ex will be 46 after execute this line. Alright, so the value of ex has become 46. In the next line, decrease ex. That means the value of the EX register will decrease 1 after execute this line. Decrease by 1. So the value of EX has become 45. Just now is 46. It minus 1 become 45. And then exit the code. And I'm going to start demonstrate lab 2 question 5 by directly execute every single line from pressing F11. Okay, for the first line, move dx 0. That means move value 0 into dx register. For now, the value of dx is 10AA. So after execute, I expect to see the value of dx will become 0. And this line is used to clear dx. Alright, so as you can see, the value of dx has become 0. And for move dx 0, we use it. We want to clear dx is because after that we're gonna use dx to store the overflow bit from the x. And this line, next line, move x 1000 hash. This means the value 1000 hexadecimal value will be stored in x register. For now, the value of x is FD58. So after that, I expect to see the value of x will become 1000. Alright, as you can see, the value of x will become 1000. And then next line, move cx 25 hash, which means the value of 25 hexadecimal will be stored in cx register. For now, the value of cx is 10AA. So after that, it will become 25. Alright, as you can see, the value of cx has become 25. And the next line, mouse cx. That means it will multiply the value of x with the value of cx, and the result will be stored in dx across x. In this case, it is a word size operand. Since cx is only 2 byte, which is 4 digit, and x is also 2 byte, 4 digit, so it can maximum goes up to 4 byte, 8 digit, because x is 4 digit and cx is 4 digit. So, but the result, the x only have 4 digit, which is 2 byte to store. So another 4 digit, another 2 byte will be stored in dx, which also means that dx will store the overflow bit, the left side of the 4 bit, which is the most significant bit, the overflow bit. Right. In this case, x is 1000 hexadecimals and cx is 25 hexadecimals. 1000 multiplied with 25 will become 25,000 hexadecimals, and 25,000 have 5 digit, and x can only store up to FFFF, so it is more than FFFF, and x will only store 5000, which is the right 4 digit, and the overflow one will be stored in dx, which is 2, the most significant bit. That's the result aspect. X will become 5000 and the dx will become 2 after execute this line. As expected, the value of x will become 5000 and the value of dx had become 2. And then I'm gonna call dumbrex. Also, the dx is used to store overflow bit, just I said, and x store 5000. Yes, is the value, is the result, and in total 25000. And then call dumbrex is to display the value of the register. And also the carry flag, the overflow flag, and parity flag, etc. Alright, so as you can see, after execute that line, the value of register had displayed, and also the carry flag, and etc., overflow flag, parity flag, and you can see that the carry flag is 1. It is because the overflow bit had assigned to dx, and that means upper half of the product is non-zero, which is the left side of the 4 digit. And then overflow flag is also 1 because it had overflow occur, which is the 2. And then we're gonna exit the code. That's it. Thank you, doctor. That's all of my demonstration.